Alright folks, hello and welcome to this video lesson on section 4.5, solving quadratics by taking square roots. As always, I suggest you copy these notes and examples into your notebooks so you have them for future reference and study. For this first page, I'm going to talk you through some definitions and terms that we'll need for the rest of the section, but feel free to pause the video if you don't have enough time to write down all the terms. So let's get started. First, remember, a number r is a square root of s if r squared equals s. That's simply another way of saying that when you have the square root sign and square root of s, well, it can be posed as a question, what times itself equals s? And that what, or that question mark, is the r in our definition. So you know that, a square root. Next we see the expression square root of s is called a radical. Sometimes we say radical s. And it contains a radical symbol, the sign right here. Okay, you might say square root of s, or you could say radical s. Either one is fine pronunciation for that term. Now notice that any positive number has two square roots. So if you were to take the number, let's just say 49, to make it easy. Well, this has two square roots because there's two solutions to the equation r squared equals 49. Well, what are the solutions? Hopefully you would know that r equals either 7 or r equals negative 7. Okay, two solutions, a positive solution and a negative solution. Next term, the positive square root is called the principal square root, and it's denoted square root of s. So if you see square root of s, it's automatically talking about the positive square root, or the principal square root. You're not worried about this other answer, r equals negative 7. So if I were to write square root of 49, that only equals 7. Square root of 49 does not equal negative 7. Okay, by convention, the principal square root is what is denoted by just the regular radical symbol. And the last terminology is that the radicand is the expression beneath the radical symbol. So the stuff underneath here, the 49, the s, that expression is the radicand. If I were to make it a little more complicated, x squared minus 3, let's say, then the x squared minus 3 is the radicand. And that's how those terms work. Keep in mind, we're not going to be dealing with negative square roots in this chapter, or square roots of a negative. If the radicand is less than 0, then we are not going to be able to evaluate it because it does not have a real number answer. So the square root of a negative has no real, there is no real number answer. It does have an answer, but we're not going to get to that until later on. So for now, if you end up taking the square root of negative, when you're solving, you could say that that means no real solution. So first up here we have some basic properties which work for any real numbers a and b. So these are some basic properties of square roots. The first one being that the square root of a times b is equal to the square root of a times the square root of b. So any square root can be split up along these lines, or if you have two square roots that are multiplied, you can combine their product into the radicand. Same thing with division. The square root of a fraction, or the square root of a division problem here, square root of a over b is equal to the square root of a divided by the square root of b. And we'll use that property to simplify these two problems below. In example 1, I'm going to notice first if there's any perfect square factors of either 6 or 21. Is there any number like 4, 9, 16, or 25 that's a factor of those numbers? And unfortunately, no. So I'm going to apply property 1 and multiply 6 times 21, which will give me the square root of 126. This expands the possibilities because now instead of checking up to 25 for perfect squares, I can check up to a lot more. So I'm looking for a perfect square factor of 126, and it looks like 9 is going to do the trick. Okay, 9 goes into 126 evenly with no remainder, so I can break up this square root into the square root of 9 times the square root of 14. And now we just need to rewrite the square root of 9 as a whole number. Square root of 9 is equal to 3, so our final answer here will be 3 times the square root of 14. Next up, we look at the square root of 7/12, and using property 2, we can rewrite this as the square root of 7 over the square root of 12. Square root of 7 cannot be broken down further, but the square root of 12 contains a perfect square factor, namely 4. So we can break that up. We have square root of 7, and then square root of 12 can be broken down into the square root of 4 and the square root of 3. You have to have one perfect square factor when you do the breakdown using either property 1 or property 1 really, to get the perfect square term there, to get to a whole number. So then this we can simplify further. It becomes square root of 7 over 2 times the square root of 3. Now, you might think you're done here. There are no other perfect square factors. However, there's a rule in algebra simplification that you're not allowed to have a denominator that contains a radical. So I'll just write that big up here. No radicals in the denominator. So the way we get rid of that is called rationalizing. And I'm going to multiply by root 3 over root 3. This is legal because that's just a form of 1. Root 3 over root 3 is 1, so it doesn't change the value of anything. And then now we can simplify. This becomes square root of 21 in the numerator because 3 times 7 is 21. And in the denominator, well, we have 2 times, and then root 3 times root 3 is just 3. So we have 2 times 3, which becomes 6. And that would be our final simplified radical answer. Now here's a more formal statement of what I stated previously, and that's to rationalize an expression means to turn it into a rational number. Okay, so rationalize, we're turning it into a rational number, and when simplifying an expression, all denominators must be rationalized. So you can have irrational numbers in the numerator, but the denominator must be a rational number, and we don't want any radicals there. So now let's look at a little more complicated example. And chances are you did not see this in Algebra 1. So to simplify this one, you notice we have 2 different square roots in the denominator. Okay, we have nothing in the numerator, but we have 2 different square roots in the denominator, and they're separated by subtraction. So we don't have a property that allows us to combine them. So the method for neutralizing or rationalizing this denominator is going to involve the conjugate, which is described below. So the conjugate of an expression a plus b is simply the expression a minus b. And the reason it's useful is because if you take a plus b and multiply it by a minus b, we know from the difference of squares pattern that that produces a squared minus b squared. There's no middle term, and you're able to square both the a and the b. That's the procedure we're going to do here. We're going to use the conjugate because when we square both of these things, the square roots will go away. And we don't want a middle term that contains square roots. And by middle term, I would mean a term that might show up like this in our perfect square trinomial. Okay, that would be the middle term, and we don't want that here. So let's make this happen. We're going to multiply by the conjugate, and whenever you multiply a fraction by something, you should use the same expression in the numerator and denominator, because that will be a form of 1, which will not change the value. Okay, it never changes the value of an expression to multiply by a form of 1. So that's my conjugate. Now just be careful when you're multiplying here. You might want to throw some parentheses around these binomials just to remind yourself that these are indeed binomials. We'll distribute the 5 and get 20 root 3 plus 5 root 5. And then in our denominator, we want to do 4 root 3 times 4 root 3. Be careful there. That's going to be 16 times 3, which is 48. And then you can look at the middle terms, but you don't really have to. Okay, this distributed to the root 5, and then the minus root 5 also distributed to 4 root 3 are going to cancel out when you add those up. So all you have to do is look at the final term, negative root 5 times root 5, and that's going to produce minus 5. And our final answer will simplify to 20 root 3 plus 5 root 5 divided by 43. And that's the procedure of multiplying by the conjugate. You can show out the full FOIL method if you need to. My point is you don't need to worry about the middle term or the O and the I of the FOIL method, since whenever you're using the conjugate, they're simply going to cancel out. Okay, lastly, just a comment on a crucial distinction that students often will mix up, and that's the difference between a principal square root and taking square roots. So let's look at just 2 examples here. On the left, I have the square root of 64. I said earlier in the video, this automatically means only the principal square root, or the positive square root of 64. So the answer to the square root of 64 is simply one number, 8. That's it. No negative, no plus or minus, nothing. just the 8. Whole number 8 is the principal square root or the positive square root. Where students get confused is when they go to solve an equation like this one here. Because in order to isolate the x variable, or get x by itself, you're often told to take the square root of both sides. Well, you know what? I'll show it in 2 steps. Let me rewrite the equation, and I'm taking the square root. And when you're doing the action of taking the square root, you need to account for all solutions that make the equation true, or all the possibilities for x. So when we take the square root of x squared, well, x equals, we say now, plus or minus 8. Because x could be positive or x could be negative. We don't know which one is the solution to this equation, because when you square a negative number, you get positive 64, and when you square a positive number, you also get positive 64 if it's 8. So you need that plus or minus when you do the action of taking the square root. Over here, remember, there is no action being done. It's simply the representation of a single number. The square root sign of 64 means the positive square root, or the principal square root, which is simply 8. But when you're taking action and taking the square root of both sides, you need to keep this fact in mind, that there are 2 solutions. All right, so let's summarize and wrap this up. We looked at several things in this video. We first looked at the terms involving radicals, like radicands and radical symbols and things of that sort, so you can review those definitions. We looked at some basic properties with fractions and with products of radicals. We saw how to use the conjugate to simplify an expression when there's a binomial in the denominator or multiple radicals. And lastly, for number 4, we looked at the difference between the simple principal square root and the action of taking a square root. Thanks for watching this video lesson on section 4.5.